Welcome to part 2. One more example as I promised. So here I want you to evaluate the limit as x goes to 0 of 1 over x plus 4 minus 1/4 over x. I'll give you a hint. You're going to get the indeterminate form and need to do some sort of algebraic technique, so I want you to try to figure that out. Pause the video, unpause if you get stuck, or when you want to check your work. Alright, so here we get the indeterminate form when we initially do direct substitution. So what's our technique here? Well, let's get rid of the fraction in the numerator. So multiply the numerator and denominator by the least common denominator of the numerator, which is x plus 4 times 4. So if I multiply the numerator by that, I have to multiply the denominator by that. Do not distribute in the denominator. So in the numerator, when I multiply x plus 4 times 4 times the first term here, the x plus 4 cancels and I'm left with just 4. When I multiply by the second term, the 4's cancel, and I have this negative, so you need to remember to distribute the negative, so it becomes minus x minus 4. It's very important that you do that, so that these 4's will cancel, 4 and negative 4, and then I'm left with just a negative x in the numerator, so the negative x will reduce with the x in the denominator. Don't forget that that's a negative 1 though. So now I have the limit as x goes to 0 of negative 1 over the quantity 4x plus 16. Now I can do direct substitution and I just get negative 1/16. Okay, so when finding limits analytically, try direct substitution first. Actually, whenever you're finding limits, try direct substitution first. If the limit of f of x as x approaches c results in an indeterminate form from the direct substitution, try to divide out common factors or rationalize the numerator or do some other sort of algebraic technique so that direct substitution will work. This method, or you won't always be able to algebraically simplify it, so you might have to use a graph or a table to either find your result or to reinforce your result. Also, again, with the amount of work you need to show, I want to see that you're getting the indeterminate form. I want to see whatever algebraic technique you're using. Every step of the way until you start to do the direct substitution, you should be writing the limit part as well. That's the end of the video.